platform so that you can play it back anytime. So let's go and take off from where we ended the other time. The other time we came to the conclusion that if you have any data, let me put it this way, if you have any frequency data, if you have any frequency data, there are three things you can do about it. The first thing is to find what we call the distribution. So you saw us do some long tables where we had class intervals and frequencies and the rest. So the first thing you can do about it is the distribution. The distribution talks about the shape of your data. The shape of your data. So to explain this one for you, I can go back to what we did to see this is what we did. And we had these frequencies. So when you are asked to sketch the shape of this frequency distribution, you can do it in a very nice way. I won't ask this question though, but I want to give you an idea of how the shape will look like. So if you take a data like this and you want to shape it up, that is where we use the histogram. You did it some time ago. So like the first one, 40 to 49, you get the shape of one like this. And then 50 to 59, 8 is longer than 1. So you see that the block will start moving up. And then you come to 27. So 27 will also move a bit up than the 8. And then from there you go to 29. So that 29 will also move up somewhere like this. And then come to 21. So it means that the block is dropping now. So from 29, it drops to 21. From 21, it drops to 9. From 9, it drops to 4. And then from 4, it comes back to 1. So when you are asked to talk about the shape of this data you have, all you do is you join one corner of the block to the other. So when you were in the secondary school, we used to call it frequency polygon. So you have a certain shape like this. Okay. So this is what we call our frequency shape or our frequency distribution. Frequency distribution. It gives us an idea that something is happening to this data. That is, once upon a time, the data was low, it moved up, it got to a point, and then started coming down. It didn't go up again. It started coming down this way. That was the first thing we learned when we were doing the frequency distribution. And that is what I've started writing. I just want you to know the things we learned. So if you see frequency distribution, it's just the shape I've gone to draw whereby we had something like this. Okay. And then after the shape, which the table gave the shape, we also learned about something called the average. The average or the center of the data. Why the center? The center because we want just one number to represent all the other numbers. One number to represent all the other numbers. Okay. So it was a number that will exactly sit at the center, somewhere here. So we had our average somewhere in the center of the shape of the distribution. But we didn't stop there because we said if we leave the story at the center alone, it will be misleading because we wouldn't know where the data is starting from and where the data is ending. At least we must have an idea of where the data is starting from and where the data is ending. Okay, so how do we do that? It means we are now going to move from the center to the starting point. We move from the center to the starting point, and then again we move from the center to the ending point where we stop. So that was the third thing we learned. So the third thing we learned was that the distance between the center to where we start and the center to where we end, we call it the variance. So the variance show us where we are starting and where we are ending. And that represented the spread of the data from the center. So these were the three things we learned about our frequency data. Now, where do we have frequency data coming from? Frequency data comes from past events, and present events. Past events and present events. That is what will help you to generate the frequency data. Before I leave here, let me give you a last example to understand this very thing that we did the last time. If I take your class and your class is following a shape like this. Okay, your class is following a shape like this. So for instance, I'm looking at, even though I haven't seen all of you before, I want to look at the height of the students in this class. So let's say the students in this class are 11, like this. Okay, good. Now, if I want to look at the height and I want to use a standard, I will say that I'm using the class rep as the average. I'm using the class rep as the average. In other words, if the class rep, for instance, is about 5 feet, 10 inches. Okay. If the class rep is about 5 feet, 10 inches, and this is level 300 top up class, level 300 top up procurement class. And I'm making the class rep the center. So that was what we found the other time. That is the average. It means I'm going to use her height as the average because I know it. I've recorded it. So this is her height. Now, does it mean it's only the class rep who is in this class? No. The class members are 11. So when I take the class rep out, there are 10 other members in the class who are supposed to align to the height of the class rep. So all those who are below the height of the class rep will find their way to the left. And all those who are taller than the class rep will find their way to the right. Okay. So it means that I'm having the height shape in this way up to this point. How do I determine who is the shortest in the class? How do I determine who is the longest in the class or who is the tallest in the class? That is what we learned with the variance. The variance can be able to show you who is the tallest in the class, who is the shortest in the class, using the height of the class rep. So this one is called the frequency distribution. Frequency distribution. And so to get the shape of the frequency distribution, you always need the average and the variance to be able to get the shape of the distribution. And that is the whole story about analysis. Anytime you are doing analysis, you need to know the center of your data, the variance of your data, and these two are going to help you to finally see where your data can be started from and where it can end. And this was frequency distribution. And I said, and I repeat again, that you can only get frequency distribution data from two sources: past events, and then the second is the present events or current events will give you the frequency data. Why? Because they have already occurred or it has happened already. So you have the records. In statistics, we call it historical data. Historical data. It has happened already. So you have your data and you can then go ahead and find the average, find the variance, and find the shape of the data. But in life, you can't always use past data and present data to plan. You can't always, it is not enough to use past data and present data to plan for tomorrow. There is another type of data we want to learn today, which is called the future data. The future data. Sometimes it is good to use the future data to plan. And look at what we've done to ourselves as a country, or most people in Africa have done. My information is that during those of you who are older enough and probably older than me, my information is that during Nkrumah's time, the population of Ghana was about 3.5 million to 4 million. This was the population around 1957. So if somebody has any other information, you can correct. But this is what I have read, that around 1957, our population was between 3.5 million to 4 million. Now we are 69 years. After 69 years, my information is that the population is around 35 million. 35 million. That is the information I have. which is 10 times the population during Nkrumah's time after 69 years. Now look at what we did to ourselves. Because in Nkrumah's time, we were using past and present data to plan for the future. When we were doing the Temamoto way, and I'm sure most of you are familiar with the Temamoto way. When we were doing the Temamoto way, we just did 2 lanes in and then 2 lanes out. 2 lanes in and then 2 lanes out. Even though there was some vast land around the 2 lanes in, 2 lanes out. And this was done for 3.5 million people. And I'm sure the engineers and the managers around that time, they weren't planning with future data. They weren't planning with future data. If they had planned with future data, they would do some exponential calculations whereby they can predict that after 69 years, this population of 3.5 is going to move to 35 million. As a result, there will be a lot of movement on the motorway. So what do? Let's use future data, not present data, to plan. And they could have increased the lanes. I traveled to Czech Republic and I got to a highway which was done long, long ago, whereby when you are going in, those going in on the motorway, you have 8 lanes here. And then those coming in, 8 lanes here. So in all, 16 lanes, 8 here, 8 here. Why? Because they use future data and they did some exponential calculations and saw that the population is going to increase. So let's create the space once and for all so that there wouldn't be congestion in future. And that is what future data can do if you use future data to plan. As a result, we want to have an idea of how this future data is planned by treating our new topic today called the probability theory. Probability theory is used to generate future data, and then you can go ahead and plan with the future data. The word probability, we can use one word to describe it. So anytime you hear or you read about probability, it's coming from the word probable, or some call it likely. But the easier way you can remember it is chance. Probability is all about chances. It's all about chances. And so it doesn't have a present data or a past data. It can only generate a future data. So we want to look at this theory and then we see how we can apply it in real life. Now, if you pick some organizations or most organizations, sometimes you have managers doing a lot of planning, and their planning are based on certain decisions that they make. Why? Because they know that in the future can be positive for the organization or the future can be negative. So in that sense, you have to do what we call a calculated risk. a calculated risk. You can't sit down and fold your arms. You have to do a calculated risk and see how to respond to issues or problems when they come up. For instance, as a manager, you can ask yourself this question: what are the chances that when sales decrease, when sales decrease, it means you increased prices? Or the reverse, what if you increase prices? When you increase prices, are you going to decrease your sales? That is a decision to take. That is a risk to take as a manager. Or when it comes to investment, you can ask yourself, what are the odds? What are the odds that a new investment will be profitable? You know, some of these investment issues we've experienced in the past in our country. So sometimes you count the risk. Are you going to take all the organization's money, not your personal money, but the organization's money? Are you going to take all and then dump it in an investment you are not sure about? So because you don't know the future, you have to always do some calculated risk so that when the shock comes, you will be able to absorb the shock. Now, all this risk can be classified as uncertainties because you are not certain about the future. So these are the words you can use. You say, in the unlikely event, it means that you are not expecting the status quo. In the unlikely event, it means you are not certain. Or when you say that with certainty, if you say with certainty, then this one you are sure of what you are talking about. But when it comes to in the unlikely event, what are you going to say? So it all falls under probability theory. So probability theory has so many definitions in books, but I want to define it in a simple way for you that you can say that probability is the measurement of chance. Probability is the measurement of chance or your chances. You want to measure your chances of risk in the future. You want to take a risk. It must be calculated. So just as we did the frequency distribution, just as we did the frequency data, which gave us these three things: the average of the data, the variance of the data, and then the shape of the data, like the histogram I drew for you. In the same way, our probability is going to generate some probability data for us. Out of that data, we'll also find the average. But for that average, we have three terminologies we use in describing the average of a probability data. The first one, we call it the mean. The second terminology is also called expected mean. So some books write it as expected mean. And then the third terminology you are likely to find in books is called expectation. So these are the three words that are used to describe the center or the average of a probability data. So we do that. And then two, we'll find the variance. As for the variance, it is the same. It has no different name. It's the same as the way we treated the frequency data. And then finally, also, we'll look at the shape of the data. So same three things we did on the frequency data, we'll do same on the probability data. Let's look at the measurements now. How do you measure probabilities? We have three conventional ways. Probability measurement, for your information, it starts from 0% to 100%. So that is the range, that is the stretch. So it means that you can have a probability of 1%, probability of 2%, probability of 3%. So it continues till you get to probability of 99% and then 100%. Okay. So that's the stretch. Now, when you are writing it in decimals, it is 0, 0.5, and then 1 in decimals. So when you want to change it from decimals to percentage, you just multiply them by 100, and then you get a percentage. But let's look at the three conventional ones, common ones that are used in the system. The first one is when you say your probability of any event, E, P of E like this, probability of any event equals 0. What is the meaning of probability of any event equals 0? It means that the event is unlikely to occur, or it is impossible for the event to occur. Anytime you hear that your probability is 0, it means it is impossible for the event to occur. Example, if somebody says that, oh, I wish you a happy birthday, you will live to become 1,000 years. Even though this is a good wish, this will never happen. It is impossible to be 1,000 years with the kind of biological body we have. It is impossible. Unless maybe some spirituality comes in. But I'm talking from the natural perspective, that naturally it is impossible to grow to 1,000 years. So if you are asked that, what is the probability of becoming 1,000 years on earth naturally, devoid of any spiritual enablement, but just on the natural level, the probability is 0. So that's the example for when they say a probability of an event is equal to 0. Now, the second conventional one is when they say the probability of the event is equal to 0.5. And if you want to change this one to percentage, you multiply it by 100. So it's the same as 50%, probability of 50%. This is what we call 50-50 in Ghana. When they say your probability is 50-50 or your probability is 50%, it means that the event can occur or it will not occur. It is likely or it is unlikely, or the event can occur or will not occur. These are the two situations that the possibility is 50-50. It's either possible or it is impossible. Unlike the first one, which was entirely impossible. That one is non-negotiable, entirely impossible. But if you take this one, it can either be possible or it may not be possible. For instance, with this same birthday wish, if somebody say, may you live to become, probably when you were celebrating your birthday, you were 50 years old, golden jubilee. And then the person wishing you happy birthday is saying that, may you grow to be a 70-year-old person. Okay. In that case, this is where we find ourselves. It can either be possible that you get to 70 years, or it may be impossible to get to 70 years. Like we all know, naturally, anything can happen. So that is where we see your probability is 50-50 or 0.5. Then the last conventional measurement, when they say your probability of your event is exactly the number 1. Okay. This one means that surely the event will occur. It's certain. Nothing can change it. That it is certain that the event will take place. For instance, you have a class with me online, and then before you came, I was there. My name has registered as one of the participants. So my name is there. And then you join the class. I'm sure your mind will never tell you that even though you are seeing my name there, the class will not come on. You know that once you have seen my name there, at least if the class will not even come on, I'll speak. I'll speak to you that today we cannot have the class. The mere fact that you are seeing my name there should tell you that something will be spoken before the class ends. And that's an example of probability is equal to 1, or probability is equal to 100%. I told you that when you are changing the numbers from 0 to 1 to percentage, just multiply each of them by 100% and you get 100%. So these are the measurements that are used to measure every form of chance that you want to measure. Okay. Now we've spoken a lot about chance, probability, chance, probability. It is time to look at the source of the chance. Where is the chance coming from? Where do chances coming from? What is the source of a chance? That is the next thing we want to look at. Now, the source of a chance or probability comes from this term, random experiments. Random experiments produces chances or initiates probabilities. That is the source. And we need to examine the source. of probabilities and chances. It comes from random experiments. And the next question is, what is a random experiment? You've experienced it, you've seen it every time in most of your activities. And these are examples of random experiments. All the experiments in business, all the chance calculations in business have their root cause from some of these random experiments. Now, the word random means that we have an unstable result. So random comes from randomness, instability, randomness, instability. If I want to create a picture for you, yeah, but also no, don't worry. So I'm using I'm using my link to do that. So when I finish up, okay, bye. So let's continue. I was saying that the randomness is in such a way that you have instability. And to create a picture for you, look at those of you who have baked popcorn before, or those of us who don't bake, but we see people baking popcorn. When the popcorn is being baked, just watch the movements of the pieces of corn or maize. Look at their movements. They move up and down, and they don't actually follow any pattern. They don't follow any pattern because you see one corn around the side, just a second, you see it somewhere here, another second, you see it here, another second, it comes here. That is what we call randomness. And so when you come to real life, there is a lot of randomness in real life. A lot of randomness. For instance, if you're at a filling station, if you are at a fuel filling station, and then you are there with your vendor to serve cars coming. The question is, how many cars are you expecting to come to buy fuel that day? You cannot predict because one moment on a particular day you had 100, another day it may decrease to 80, another day that you think nobody will come, you have about 300 cars. That is randomness, and it's typical of the movement of the corn in the popcorn baking machine. So that is randomness. So when we say an experiment of randomness, it means an activity that can portray the randomness we are talking about. So when you take a coin, one, the coin has two sides. You have the initial front side, and then you have the other side. Okay. Now, when you are tossing a coin, we say you are performing a random experiment. Why? Because you do not know the results until the coin falls on the ground. When the coin falls on the ground, the initial part, which is the front part, is called the head. where sometimes we represent as H, uppercase. And then the other side is called a tail, which sometimes we also represent as T, uppercase. So when you are tossing the coin, you do not know whether a head or a tail will appear until the coin falls on the ground, because it can be either head or a tail. So this makes this activity a random activity. Why? Because H can appear or T can appear. The second one is when you are in a manufacturing plant whereby products are being manufactured. All the products that are being manufactured, when you do a thorough inspection, you'll see that not all products are the same. Some are defective. Some are non-defective. The question is, whilst the manufacturing is going on, how do you know the number of products that will be defective? How do you know? That is randomness. We all see that typical. If you buy a bag of water, a bag of sachet water, which I know a lot of you do. Now, sometimes when you split it open and you start using the water, you can meet a particular sachet whereby it is almost flat because the water that was put in was not enough. It was almost flat. Now, the question you ask yourself is, why didn't they see this one in the factory to remove it out? No, because of the bagging process, you cannot remove it. So it means that randomly, there may be a mistake or an error in the filling of the water. And that is a random experiment. Now, the other popular one is the third one, which is business sales. You all know what happens in business. 3 clear block scenarios. Either you are going to make profits on a business day, or you are going to run a loss on a business day, or you are going to break even on a business day. On the morning of the business activity, you cannot determine which of these ones will happen to you, even though the main objective for you is to make profit and nothing else. But it doesn't always happen that way. Something may come in called business shocks that can knock you off at a particular time. So the random experiment here is that you should condition in your mind that you are either going to make profits, or you run a loss, or you are going to break even, because your business sales qualifies to be a random experiment or a random activity. Let me give you a clear example. Those of you who follow the business news, 3 weeks ago, the crude oil on the world market, those of you who were following it consistently, 3 weeks ago, I think it was about $62. Then 2 weeks ago, same crude oil, we saw that the price shot to $88. A week ago, same barrel of crude oil shot to $104. And I think 3 days ago, it came back to $79 or so. I don't know the current one today. The ones I have tracked is what I've written here. Now look at the randomness. 3 weeks ago, $62. 2 weeks ago, $88. A week ago, $104. 3 days ago, $79. How do you plan with this inconsistent figures? How do you plan with this? This is where we say this movement is a random experiment. Why? You cannot predict the results until it happens. Until it occurs, you cannot predict. But you're a business person. So if you bought crude oil at 62 and then you were selling it at 72 and you ran out of stock, let's say you had about 1 million barrels, you sold all at 72, and then you came back to the market again, and then they told you that this time what you bought at 62, this time it is $88. Look at the money you are having. It has pushed you totally into a big loss. You try to gather yourself, you came to buy the thing at $88. You bought about 2 million barrels thinking you can keep it for long and make your sales, only for the 2 million barrels to finish within a short time. You bought it at 88, you were selling it at 98, and then you came back to the market again to source for more, and then the price has shot to 104. How can you then predict your profits? How can you do that? That is the randomness in business sales. The fourth popular random experiment is the Ludo game we've been playing, the rolling of a die. You all know that the die we use in playing Ludo has 6 square surfaces. So you have the 1 surface, you have the 2, you have the 3, you have the 4, you have the 5, you have the 6. Then how can you be able to know whether you are playing 6? And most of you do it in a funny way. When you are playing 6, you shout 6, thinking that it is your shouting that is bringing the 6. No, your shout doesn't bring the 6. What brings the 6 is probability, because it is a random experiment you have engaged yourself in. So in the same way, it will take randomness to record your results. So that is what probability does. It's going to give you a result, and then you will know. You cannot know it from first hand. The last one I want to give you, which those of you who like soccer or playing of football is a random experiment. Why? With all the players you may have, with all the hope you have, there are 3 things that can happen in football, no matter how big you are as a club. You will either win on a day, or you will lose on a day, or you play a tie, or what we call a draw. So even though you have some bragging rights about your team, you yourself, deep within you, you know that one of these 3 will happen. And that is called random experiment. So to put it all together, random experiment is an activity whose results you cannot determine until it happens. But you have an idea of what the results can be, like we have done here. So you see that the different random experiments you are seeing, their results are different because of the shape of their randomness. So for instance, for rolling of a die, you know that there are 6 chances. The playing of a football, you know there are 3 chances. The tossing of a coin, you know there are 2 chances. So depending on the activity you engage in, it will determine the number of chances you are going to deal with. Now, I showed you all these things because sometimes we do make some statements when we are trying to predict for the future. So, for instance, sometimes we make qualitative statements. What I mean by qualitative statement means that you don't attach numbers to the statement. So we make qualitative statements such as the chance of a head appearing in the tossing of a coin. Look at it. The chance of a head appearing in the tossing of coin is very high or very low. The chance of appearing in the tossing of a coin is very high or very low. Can you imagine that? How do you measure very high? How do you measure very low? Because your low is somebody's high, and your high may be somebody's low. So it is often dangerous to try and describe your chances with qualitative statements. The best way to go about it is to describe them with a quantitative measurement. Once you bring the quantitative measurement, it helps in decision making so that when people are taking risk, they will be careful. If you tell somebody you are an agent, all you do is that you send people abroad, but there is a risk factor. The risk factor is only 10%, meaning that 90%, meaning that 90% of the time, 90% of the time, the thing works through, it will go through. Or what you want to say is that if you are taking 10 people, 9 out of 10 will go. Only one person will not go. This is a high probability. And so our risk, again, if another agent tells me that, oh, as for me, when I'm taking you outside and you pay all the money, the chances are 50-50. The chances are 50-50. It means that you may have it or you may be rejected. 50-50, you take a risk because you are looking at the quantitative. You are looking at the measurement. 50%, okay, that's good. But if a third agent comes and says that I'm also an agent and your chances of qualifying to travel is 8%, meaning if I'm taking 100 people, only 8 can go. This is a low probability. So it is very risky to engage yourself in such an activity. Any activity that has a low probability, it means that it becomes more difficult for you to be able to navigate to the next level. So simply put, all the random experiments we want to look at, we are going to use quantitative measurements to describe them. We will not use qualitative statements to describe them. We'll use quantitative measurements to describe them. And so I want to break down the data for you, and then we can see whether we can do some calculation before we end the lecture today. Now, the random experiment produces two kinds of data. The first is called discrete data, and the second is called continuous data. Now, the discrete data are observed and realized anytime you count them, meaning that to see a discrete data, it must be counted. So discrete data is countable. You can count them physically. For instance, if you are looking at the number of complaints per day brought by people to you as a manager, you can count them. If 5 people came to complain, you knew that 5 people came. If 10 people came, you knew 10 people came. Or the example I gave you, if you are in a fuel filling station and you're a fuel attendant, and then 30 cars came, you can tell your boss that 30 cars came and I have made sales on 30 cars. So that is discrete data. You have counted it. Okay. Now, what about continuous data? Continuous data is not like the discrete data. Continuous data are not countable. You cannot count them. Continuous data are not countable. Continuous data are not countable. Data that is not countable is called continuous. So if they are not countable, what can be done to them? Then it means that they can be measured. You cannot count them, but you can measure them. That's the difference. For instance, let's take your height. If I want information about your height, I cannot say I'm going to count your height, even though the measuring rod I'll use has some numbers, but those numbers are not counted, but rather the only thing I can do is to measure and not count, because your body is continuous. I can't see where your head is ending and where your neck is starting, where your arm is ending and where your hand is starting. You are continuous. The body becomes continuous. So we cannot count 1, 2, 3, 4, 5, but we can measure. For instance, if here our tape is telling us that here is 0 and here is 6 feet, it means we have measured this distance. We didn't count it, but we have measured it. Temperature of a solution. So if you prepare a cup of Milo, and then you use a very hot water, 100 degrees Celsius. When you are cooling your tea, how do you know when the temperature drops to 100, from 100 to 99, from 99 to 50, from 50 to 25? How do you know? You cannot count it. You cannot count it. You can only measure it with a thermometer. So that is a continuous data. What about time? Time required to complete a task. You cannot count time, even though you know the clock. You know where some conventional numbers find themselves, but you cannot count time. You can only measure because of the movement of it. So these are the kinds of data we'll be dealing with. Sometimes we'll have to deal with a countable data called a discrete data. Sometimes we need to count discrete and then we measure the continuous, because continuous needs measurement. And these are the two kinds of data that we can get from our random experiments. If you want to look at it in a picture form, how they look like, this is how they look like. So when we say you have a discrete data, which is countable, this is an example of a discrete data because it's in such a way that you can count them individually. So this is one, this is two, this is three, this is four, this is five, this is six, this is seven, this is eight, this is nine, this is 10, this is 11. So I've counted 11 strokes or pillars. But when it comes to the continuous, continuous, you cannot count. Look at it. It's continuous. There is no break. It's just joined. All the members or activities are joined together. So you cannot see which is one and which is the last one. So this is not countable, but this is measurable. So we measure the continuous data and we'll look at some of them in our calculations. All right, so we want to now look at the shape they can give us. Every activity has a shape, like I showed you. If you look at this one, look at this discrete, look at the shape it's giving us. It started like the histogram we did. It started and it was here, and we had this block, and then the block increased to this side, and then it increased again, and we have this block, and then it decreased again, and this block was also formed. It increased again, a new block is formed. It decreased again, another block is formed. There's another decrease here, another block is formed, and then so it has decreased again, another block is formed, same level, another block is formed, decrease again, another block is formed. And if you remember, I did show you how the frequency polygon gave a shape to this one. So we connected the edges. So this is how it goes. You connect the edges, and then you have a shape like this. So discrete has a shape. Continuous also has a shape, like you are seeing. Now, what brings about the shape? It is the random activities. It's the random activities that brings about the shape. And now you understand what a random activity is. So I'm going to take the simplest one. I'm going to take the simplest one, and then we see how these distributions or shape are generated. Let's take an example. Now, we want to see a random activity that is coming out with a shape. And we are going to use 3 coins. And probably we may end with this example, and then we can continue next week. Now you have 3 coins. 1, 2, 3. 3 coins like this. The question says that 3 coins are tossed together once. 3 coins are tossed together once. Find the probability distribution. Find the probability distribution of the number of heads appearing. I read the question again. 3 coins are tossed together once. Find the probability distribution of the number of heads appearing. Find the probability means find the chance. Find the chance distribution of the number of heads appearing. I said earlier on that the front view of the coin is what we call the head, H. And then the other side is what we call the tail, T. So now 3 coins means you have each of them having 1 H, 1 T. 1 H, 1 T. This way. So you have 1, 2, 3, 4, 5, 6 surfaces. Okay. Now, all we want to know is that what chance do we have if we throw all these 3 coins and then at the end of the day, when they land on the floor, the first coin will show head, H. The second coin will also show head, H. The third coin will also show head, H. This is the calculation we want to do. We don't want to use a qualitative statement to say that we have a low chance or we have a high chance. All we want to do is that we want to see how the chances are distributed. How the chances are distributed. That is what is going to inform our decision. So this is what we do. We need to find the outcomes. When you throw it and they land on the floor, we need to find the outcomes. The outcomes have another name which we use called sample space. Sample space. If that is becoming too difficult for you, the outcomes are the results we are going to get. The results are what is forming the sample space or the number of results we have. So let's try our hands on it. Let's see how, when you toss 3 coins, the possibilities of the outcomes you have. So if you toss 3 coins, these are the outcomes. These are the possible outcomes when we toss 3 coins. It means that, so these are the coins we have. First coin, second coin, third coin. These are the possibilities. Either the first coin will show head, the second coin will also show head, and then the third coin will also show head. This is one possibility, that all 3 of them will show head, head, head. Or second possibility, either the first will show head, the second will also show head, but this time the third will show tail, the other side. So when the coins land on the floor, you may have HHT. Or another possibility, Either the first will show head, the second this time will show tail, and then the third will show head. This is another possibility. Or the first will still show head, the second will show tail, the third will show tail. This is also another possibility. Or this time the first will change and show tail, the second will show head, the third will show head. Or the first will show tail again, the second will show head, the third will show tail. Or the first will show tail, the second will show tail, the third will show head. And then finally, the first will show tail, the second will show tail, the third will show tail. And this is going to make up our set of possibilities. So this is the first possibility. This is the second possibility. This will be our third possibility. This will be the fourth possibility. This will be the fifth possibility. This will be the sixth possibility. This will be the seventh possibility. And this will be the eighth possibility. So it means that in throwing these 3 coins, there are 8 different possibilities that can happen. 8 different possibilities that can happen. So how then do we calculate our chances? According to the question, we should calculate the chances that when you throw the coin, we'll see some number of heads appearing. Some number of heads appearing. So this is what we just did. The first one, HHH. The second one, HHT, HTH, HTT, THH, THT, TTH, and triple T. These are the possibilities we have now. And we have to take a decision on it. So how do we do that? We are going to look at how the heads are appearing. So we start in this manner, that let X represent the heads. So we use a variable to represent the number of heads. So you can write that let the X variable represent the number of heads appearing. The number of heads appearing when the coins land on the floor. This is how we go. So we check if X is representing the number of heads appearing. Then when we write X, and this is why I want you to pay attention. When we write X is equal to 0, this one means that no head, because X is representing the number of head appearing. So when we write X equal to 0, it means that no head will appear when we toss the coin. When we say X is equal to 1, it means that only one head will appear. Only one head will appear when we write X equals 1. When we write X equals 2, it means only two. It means that only two heads will appear. When we write x equals 3, it means only 3 heads will appear. So to answer the question that we should find the chance distribution, we should find the probability distribution of what? The number of heads appearing. This is what we are going to do. So we pick our x and we represent our x this way, because for the 3 coins, there's the likelihood that all the 3 heads can appear. That is x equals 3. There's also the chances that only 2 heads will appear. That is x equals 2. There's also the chance that only 1 head will appear. That is x equals 1. And also, there is also the chance that no head will appear. That is x equals 0. So that is the calculation we are going to do. So when we pick our x, then we bring the probability formula. So this is how you say this. Probability of x equals 3, meaning probability of 3 hairs appearing is equal to probability of which event will give you 3 heads. It is this event that will give you 3 heads. So probability of 3 heads can only be represented by event H, H, H. So you ask yourself, how many of this triple H are you having here? It's only one. How many possibilities are you having? You have 1, 2, 3, 4, 5, 6, 7, 8. So it means that this will be 1 out of 8. And that is what you are seeing here. 1 out of 8 is the possibility. Now, the formula that is used to write this 1/8 is called the classical method. It's called the classical method. And it's giving us probability of any event E. It's giving us sample points divided by sample space. Sample point divided by sample space. Sample space is the entire possibilities. So when you count them, 1, 2, 3, 4, 5, 6, 7, 8. So it means that our sample space is 8. So sample space is all the outcomes, all the possible outcomes represent the sample space. What about the next one, the sample point? What is sample point? Now, sample points are specific outcomes. Specific outcomes. Specific outcomes. And then sample space is all possible outcomes. So then if you take this event of 3 heads appearing, if you look specifically, you only have 1 outcome. So it means that our specific outcome in this formula is 1, which is this one. So our answer is 1/8. That is when you are expecting all 3 of them to appear. Now, what if you are expecting only two heads to appear? It means that we go into the possibilities and pick out the ones that are showing only two heads. And they are here. You can see them here. Now, this is the first one. This is showing two heads, HH. So that is one. This is another one showing two heads, H, H. And then this is a third one showing two heads, HH. So apart from this 1, 2, 3, all the others are not showing two heads. So how do you do the calculation for Px equals 2? We use the same formula. Sample points divided by sample space, where sample points are specific outcomes and sample space are all possible outcomes. So it means that the probability of X showing two heads is giving us our specific sample outcomes are 1, 2, 3. So that is 3 divided by sample space, which is all possible outcomes, which is 8. So our answer is 3 divided by 8. That is for two heads. And then that sends us to one head, which is X equals 1. One head. So we are going to pick all events that are showing one head, and then we come and process them. So when we look at our possibilities again, let's try fishing out the ones with one head. So I see one head here, HTT. So this is showing one head. I see another one head here, THT. It's also showing one head. I see another one head here, TTH. It's also showing one head. So it means that in essence, we are having three heads, three possibilities showing one head. This is the first one. This is the second one. This is the third one. So when we come to our formula for probability of X equals 1, and we use sample points over sample space, it means that probability of X showing one head will be given as 3 specific outcomes over 8 possible outcomes. So we get 3 over 8 also for X equals 1. So we have 3 over 8 for X equals 2, and we are having 3 over 8 for X equals 1. Now, what about the last one? Probability of X equals 0. X equals 0, we all said means that there is no head. So let's go and count the ones which has no head. We have covered this one, we have covered this, we have covered this. So yes, this is the one with no head. H, H, H. No head. That means that we have one. We have only one that is showing no head. So again, we write our formula, probability of an event equals sample point over sample space. So probability of no head means probability of X equals 0 is equal to 1 over 8. And that's what we have here. Probability of X equals 0 equals 1 over 8. And so when you are asked to describe the distribution, this is the final thing you write as the distribution. The question said we should find the probability distribution or the chance distribution. And this is what we have done. we are saying that whenever you are expecting to see three heads, which is x is equal to 3, your chances are 1 out of 8. When you want to see the coins showing 2 heads, this is also showing that you are going to have 3 out of 8 as your chance. If you want only 1 head to show, which is x equals 1, it means, again, you have 3 out of 8 to show. And then finally, if you want the coin to show no head, it means you have 1 out of 8. Now, conclusion of the chances we have enumerated, which we call the probability distribution. So we can therefore conclude that it is easier to see x equals 2 than to see x equals 3. Because this one, the chances are 1 out of 8. This one, the chances are 3 out of 8. And then when you come here to, it is easier to see 1 head appearing because it is 3 out of 8 than to see no head appearing, which is 1 out of 8. So if we are to plot this one on a graph, and then you see me draw something like this, and so you all know that this is the origin. So this is x-axis. This is our y-axis. You all know that this is 0, x equals 0. This is x equals 1. This is x equals 2. And then this is x equals 3. If we are plotting, when there is no head, it's 1 over 8. So you see our point somewhere here. You see our point on this axis. It's supposed to be on 0. Now, if you want to see x equals 1, this is 2 over 8. This is 3 over 8. If you want to see x equals 1, the point will be here. So that is 3 over 8. If you want to see x equals 2, that is also 3 over 8. The point will be here. And if you want to see x equals 3, that one too, the chances will be the same as this. So you see the point here. That is 1 over 8. If you try joining these points, you have a shape like this. So we call this shape you have drawn, we call it the probability distribution. That these are the chances that you are likely to have when you throw 3 coins up. Meaning that if you are expecting no head, you have a lower chance. If you are expecting to see all 3 heads, you have a lower chance. But if you are expecting to see 1 or 2 heads, you have some higher chances. And this can guide you when you are taking a risk in business. This can guide you when you are taking a risk in business. So if I'm to translate this into business, this is what it's saying, that if you invest in this one, the chances of losing your money is low. If you invest in this one, the chances of losing your money is low. But if you invest in this one and this one, the chances of losing your money is very high. So assuming a business person presents this 4 businesses before you that invest in them. The question is, which ones are you going to invest in? I'm sure you go in for the ones that has the lower risk, and that will be 0 and 3. And this is how sometimes business people calculate their risk before they venture into any form of um, business random activity. This is my last statement. Any question about what we have done today? Any question from the class? Dr. Loglo is saying that he will use the same link to meet you. So class rep, try and call Dr. Loglo whether you should stay out of class or you should still be here, because he's going to use the same link to teach you. But before that, any question from what we have done today, random experiments and how random experiments brings about probability distribution? Okay. I don't see any question coming. So let me wrap up so you can prepare for your next class. On this note, I want to thank you for your participation today, and I hope we'll continue, God willing, next week with where we are leaving off. We'll continue from there. I wish you a good week, and the class is officially ended for today.